Hi, ladies and gentlemen. So into this video, we'll be focusing on trigonometry. So it's our question. We are given that cos beta is equals to -1 over root of 5, where beta is greater than 180 degrees but less than 360 degrees. Okay. If you can check where this interval, it includes only two quadrants. Okay. It includes two quadrants, which is quadrant number 3 and number 4. So we need to know where are we going to draw these things, because they say we determine with the aid of a sketch and without using a calculator the value of sine beta. Okay, so let me just try to sketch this thing first. Okay, we'll be having a sketch like this. So let's check. Here you know it's 0 degrees, then here it's 90 degrees, here it's 180, and then here is 270, and then here is 360. Okay, so this given interval, it talks about two quadrants. Okay, so you need to know between quadrant number 3 and quadrant number 4, where are you going to sketch this diagram? Okay, so by checking here, we're having cos beta is equals to negative. Our cos is negative. Is -1 over root of 5. So meaning our cos is negative. So if our cos is negative, obviously between these two intervals, obviously the interval that we have to sketch this thing is quadrant number 3, because on quadrant number 4, the cosine it's positive. So we wanted where it is negative. So it's very much important to analyze the information and check the interval. Don't just come and sketch it without analyzing the given interval and also the given trig ratio. Okay. Okay. So let's start. This one, we know cos, the ratio of cos, let's say it's cos beta, it's given by x over r. Okay. So meaning that because we are having cos beta is equals to -1 over root of 5. Obviously, this root of 5, it's our r or hypotenuse. And mind you, the value of r is always positive because it's the length. Okay, so we're having root of 5 here. Okay, I forgot to write our angle. Our angle is beta. Okay, so we need to find, because we're having the value of x is -1. So -1 is to, we need to find the corresponding value of y here. Okay, we're gonna use the theorem of Pythagoras to find the corresponding value of y, because don't forget the question is to determine the value of sine beta, and sine beta it is equal to y over r. So if you can have the value of y, and then we're having the value of sine beta. So let's solve for y. We're going to use the Pythagoras theorem. We're going to say x squared. What is our x? Our x here, it is -1 squared plus y squared. This is x squared plus y squared equal to r squared. What is our r? Our r is the root of 5 and then squared. Okay, so you'll be having y squared equal to, this is 5 and then this one is 1. When it goes to the other side, it will be -1. 5 minus 1 is going to give us 4. Okay, then we introduce square root both sides, plus or minus. So y it equals to plus or minus 2. Okay, so let's check the diagram. By checking this diagram, our y values in this quadrant are negative. All the y values are negative, so obviously it means our y, therefore the correct value of y here, it is -2 only. The positive 2 is not the correct one. So it is very much important to draw a sketch, because if you don't have a sketch, you will not know whether your y is going to be positive or what. Okay, so I'll come here and write sine beta. Our y we've determined, okay, it's -2, so it means it's -2 over root of 5. Then we are done with 5.1. Okay, let's go to the next question. Let's go to the next question. The next question, they require us to determine the value of the following expression. Okay, so here we need to simplify. 5.2, we need to simplify it. Okay, so let's check what we are having there. We are given a tan of 180 degrees minus x multiplied by sine of x minus 90 degrees, all divided by 4 sine 360 plus x. Okay, so let's start. It has how many marks? 6 marks. The first question that we did has only 5 marks. So imagine doing all those simple things, get 5 marks, just like that. Because the thing that we need to determine there, it was the value of what? Y only. If you have y, then come and plug it there, and then you are done. So our sine beta is negative 2 over root of 5. And then you get 5 marks for doing all those things. But it's very much important to sketch a diagram. Ne? This one, it needs us to simplify. We're having tan of 180 degrees minus x into sine x minus 90 degrees. Okay, divide by 4 multiplied by sine into 360 degrees plus x. Okay, so here it's very much important to know the reduction formula and also the co-ratios, né? Or the reduction angle and co-ratios or co-function. So let's start, because this thing, if you are given an expression like this, the first thing you have to check is the angle before you go to the trig ratio. I will start with this one after. We are having 180 degrees minus x. Okay, 180 degrees minus x, it is in quadrant number 2, and we're having tan. Is tan positive or negative? In quadrant number 2, obvious tan is negative there, so it means this will change to negative tan x, just like that. Okay, we go to the next one. This one is a co-ratio. Immediately you see 90 degrees plus angle, 90 degrees minus angle, or what 90 degrees or 278, just know that one is a co-ratio. It's where you change sine into cos or cos into sine. Okay, it's very much important. So, but the first thing you need to know to check is the angle. Here our angle is x minus 90 degrees. X minus 90 degrees, it is found in which quadrant? It is in quadrant number 4. Okay, I know a lot of people will make a mistake here, because we are having 90 degrees minus x. This one is for quadrant number 1, and we have x minus 90 degrees. These are not the same thing, so you need to differentiate this one. So x minus 90 degrees, it is in quadrant number 4, meaning that sine will produce a negative result. Okay, so I will having negative, then sine will change into cos x. Okay, divide by 4. So let's check our angle. 360 degrees plus x, it is in first quadrant. Okay, so obviously, all the trig ratios are positive in first quadrant, so here we're still having positive sine x. Okay, perfect. So always when you are simplifying or when you are proving an identity, make sure we change tan, because tan, we know it is sine over cos. So always when you are solving an identity, or when you are simplifying an expression, please make sure we change tan. Okay, so before anything else, let's multiply these signs. Negative and negative here is going to give me positive, so I will no longer have those negatives. So let me change tan. Tan, it will be sine x over cos x. Okay, and then here we're also multiplying with cos x. Let me write cos x over 1 so that it can be simple to understand. All these things divided by what? 4 sine x. Okay, I hope we are still following. And then here, cos x and cos x will divide each other. We will be left with sine x over 1. If you want, you can still divide this sine x and this one, because you are going to be left with sine x over 4 sine x. So sine x and sine x will divide each other, and then you will be left with, obvious, everything that is on the numerator will turn to 1. Okay, we'll be having 1, and the denominator will be having 4. So your final answer is 1 over 4. Just 2 steps, you get 6 marks. You see, it's very simple. This is just simple. It was giveaway. Then let's go to the next question. And the next question, we are given if sine A is equals to P and the cos A is equal to Q, write tan A in terms of P and Q. Okay, we all know tan A is going to give us sine A over cos what? Cos A. What is sine A there? Sine A is given with its P. What about cos A? Cos A is Q. So tan A in terms of P and Q, it is P over Q. I hope you understand that one. Okay, it only had the 1 mark, so this was very simple. Everyone, I hope, was gonna get this one. So let's go to the interesting one. We are given, okay, simplify P to the power 4 minus Q to the power 4. Okay, so there, the first thing you need to do there is to factorize. You need to factorize. Okay, let's factorize this expression. We are having P to the power 4 minus Q to the power 4. This is a difference of 2 squares, so we're not going to struggle. We're going to have P squared into P squared, and then here we're going to have Q squared, then Q squared plus and minus. Okay, this is a difference of 2 squares, so it's very simple. And then let's come and plug. What is our P? Our P is sine A. Yeah? Sine, so it means we'll be having sine squared A minus, okay? Q is cos A, okay? So we'll be having cos squared A. And then into here we're going to have sine squared A plus cos squared A. Okay, I'll just substituted because P it represents sine A, and then Q it is cos A, so it was the matter of substituting. And then okay, if you can check very well, this one is going to give us 1. This is a identity that we did in grade 11. Sine squared angle plus cos squared angle is going to give us 1. So how about this one? This one here. This one, it is similar to the double angle identity of cos, okay? Because here they are just tricking you. If you can check, if you're having cos 2x, this one is going to give us cos squared x minus sine squared x, okay? But in this case, if you can check, it's starting by sine squared angle minus cos squared angle. So it is similar to this one, but not exactly the same. Okay, the difference are the signs only. Okay, so let me start by cos. So it's very much important. So I'll write negative cos squared A because it's negative, then plus sine squared A because it's positive. Sine squared is positive. Then I didn't change anything. I just changed the position of these two terms. Okay, it's like when you're having 2 minus 3 and then you write it as minus 3 plus 2. Okay, so you didn't change anything, only the positions. So now we need to factorize this expression with a negative. Yeah? So if I factorize with negative, I will be left with cos squared alpha minus sine squared a, not alpha, it's a. This is a, ne? Okay. That one is 1. So if you multiply by 1, nothing will change, ne? And then now we are having this double angle identity. You see, it's starting by cos squared angle minus sine squared angle. So this means our final answer is going to, don't forget this negative. If you forget negative, then it's wrong. It's going to be negative, and then what's inside our bracket is going to give us cos 2a, and then we're done. So don't left that negative behind. If you don't have negative, then it's wrong. It is wrong. Okay. Let's go to 5.4. 5.4. 5.4. Let's see what we're having there. Oh, we're having an identity. Okay. Interesting. Identity. We have to prove this identity. We're having its cos theta over sine theta, then minus cos 2 theta over sine theta multiplied by cos theta. It's equals to tan theta. Okay, even if I don't write equals to tan theta, allow me to prove with this left hand side. I will use this left hand side to prove, but indeed it's gonna give me tan theta. Okay, so this is our left hand side. So always when you are proving an identity, choose the complicated side. Choose the complicated side to prove these things. So it's gonna be simple for you. So if you can check here, we are having a fraction. We're having a fraction. So what we need to determine first is the LCD. Okay, LCD. What is our LCD? Our LCD is going to be sine theta multiplied by cos theta. That is our LCD. Someone will come and say LCD is equal to sine theta multiplied by sine theta cos theta. Wrong. The LCD is that one because you can't repeat a term. If you see sine here and repeat it here and then it's wrong. Yeah? You can't write sine theta cos theta. That is wrong. You have to go and do the basics of LCD. That's not my work to teach you the LCD. Yeah? I hope you did it. If you don't understand LCD, then yeah, it's too late for you. Or it's not too late. You can simply join our sessions. Yeah? You can join our online sessions. I will show you how to determine the LCD. Okay, but I hope some of you will understand how to determine this LCD. So let's continue. LCD, it's going to be sine theta cos theta. Okay, then if you want to know what are you going to multiply with here, it's simple. We just come right and say LCD divided by the denominator of that term. Ne? The denominator is sine theta, so it means LCD is what? Sine theta cos theta. Okay, divided by that LCD sine theta. So it means this part you are seeing it here, I'm going to multiply with cos theta because I will be left with cos theta. So it will be cos theta multiplied by cos theta, okay, which will be cos squared theta. Okay, it will be cos squared theta. It will be cos squared theta. Cos theta multiplied by cos theta becomes cos squared theta. And then this side obviously going to multiply with 1. So let me just leave it. So cos 2 theta. Okay, cos 2 theta. So here you must be very, very careful because this one, you change it in 3 different ways. Né? So if you want to know how can I change this? Because we're having cos squared theta there, it means this one you're going to change it in the terms of cos squared theta. So I'll come here and write 2 cos squared theta minus 1. That's how I'm going to change this cos to theta. Okay, and then let's simplify this thing here. I will be having if you can check this thing, these two things is going to give me negative cos squared theta because look, we're going to have cos squared theta minus 2 cos squared theta, and then negative times negative, it's going to be positive 1. So this 2 is going to give you negative cos squared theta. It's like when you're having x squared minus 2x squared. Obviously, you're going to get negative x squared. So here we'll be left with negative cos squared theta. Okay, I hope you understand. So let's come and write it here. And don't forget, we're having positive 1. Let me start with positive 1 minus cos squared theta. Okay, because negative and negative, it will give us that positive 1. And then cos squared theta minus 2 cos squared theta, it gives us minus cos squared theta. Then divided by sine theta cos theta. Okay, if you can check our numerator, this is an identity. It will change to sine squared theta. Okay, so we'll be having sine squared theta over sine theta multiplied by cos theta. Okay, so if you can check this very well, sine squared theta will divide with sine theta. Obvious, on our numerator will be left with sine theta, then the one on the denominator will be divided, so it will be left only with cos theta. Okay, what is sine theta over cos theta? We all know this will give us tan theta. Okay, do we have our identity there? We have to do what? Prove. We prove that identity. Indeed, this whole expression, it will end up giving us tan theta. We are done with that one. Okay, let's go to the next question. Let's go to the next question. The next question says, for which values of theta in the interval theta is greater than 0 degrees but less than 180 degrees, will this identity be undefined? Okay, for something to be undefined, it means the denominator must be equal to 0, because if you're having any number or any constant divided by 0 or any variable divided by 0, that is undefined. That is undefined. Anything divided by 0 is undefined. So it means we must let our denominator to be equal to 0. Okay, Yes, we have to do that. So if you can check very well, let me start with the right hand side. Yeah, tan theta. Tan theta is the same as sine theta over cos theta. I hope you can agree there. So I'll let this denominator to be 0, okay? And then solve for theta. Cos theta will be equal to 0. My denominator, I've equated it to 0, okay? So let's solve. Theta is going to be, again, simple, press shift cos and then insert this 0. You're going to get 90 degrees, okay? You come and check. Is 90 degrees in this interval? Yes, it is. Perfect. Okay? Then you go to the left hand side. You see here we are having sine theta. Because we have dealt with cos theta, let's just leave it. Let's focus on sine theta. We must also equate sine theta to 0 because it is also our denominator in this identity. Okay, so let's solve this one. If you say shift cos and then you put z, no, we are focusing with sine. If you say shift sine and then you put 0, shift sine then you put 0, I think we're going to get 0 degrees. And the 0 degrees is not on our interval. It's not in our interval. So we don't write it. So the only solution here is 90 degrees. You must be very careful. Look, this was a tricky question. It is 0 degrees less than theta less than 180 degrees. So it means this 0 degrees is not included unless if they written less than or equal to. Then I was going to write that 0 degrees. You understand? So because there is no included sign there, 0 degrees is not included. So the only solution there, it is what? 90 degrees. It is fits in this interval. So must be very, very careful when it comes to this. Focus more on that interval. Okay? Then we're done with 5.4.2. Let's do the last question. This is the last question. General solution. One of the easiest equations to solve, general solutions. This one is very simple. Let's write it. It is what? 2 sine 2. Oh, it is 2 sine 2x, okay? Plus 3 sine x equal to 0. All right, so here we are having a double angle identity. This one sine 2x. So we need to change it. Change it to 2 sine x multiplied by cos x, okay? I hope you all know the double angle identity by now, okay? Because now we're doing a revision, we're not starting something from the beginning. Then 2 multiplied by 2, we're going to get 4 sine theta, sine x, sorry. I used to write theta most than x, sine x, and then cos x, okay? Yeah, because 2 multiplied by 2 to give us 4 sine x cos x plus 3 sine x equal to 0, okay? It's equal to 0. Then you can see we have a common factor of sine x. So let's take it out. Sine x will, so let's check what we're going to be left with. We're going to be left with 4 cos x plus 3 equal to 0. Okay, I hope you know how to factorize. Then now what we're going to do is to write our sine x obviously is going to be 0, or cos x is equals to negative 3 over 4. Okay, so this is very simple. You can come here and write x is equals to, let's focus on this one first. Let me write it with another color so that we can differentiate them. You can see now I want to write this, so I want to focus on this one. So sine x is equals to 0. If you say shift sine, then you put 0, you're going to be left with 0 degrees. So x is going to be, this is a general solution. So you come and add 0 degrees plus 360 multiplied by k. Yes, into k element of all our integers. That's it. Or even if you don't write 0 degrees, because if you add zeros, nothing, you can write it as x is equals to 360k, just like that. Then you write k element of all integers. But even if we have written 0 degrees, it doesn't mean we are wrong. Another solution here, because another solution, it is, if you can check, I hope you have the basics of general solution. Another solution is going to be 108 minus 0 degrees. So if you subtract 0 degrees, nothing going to change there. So let me just write 108 degrees only, because if I subtract 0 degrees, then I will still be left with the very same thing that I'm having. Okay, then those are the two solutions. It is for this one. Okay, I was dealing with this one only. So now I want to focus on cos x is equals to negative 3 over 4. Okay, so it's the very same thing. So this one is simple, even it is special. So we come and write shift, and then you insert cos negative 3 over 4. Okay, we're going to get what? 100, and let me come and write it, 138 degrees, comma 59. Oh, sorry. Ish, it's been too long without writing this degrees thing. Okay, 138,59 degrees plus 360 multiplied by k into k, the element of all our integers. Okay, so I need you to know something here. For cos, we come and write it, plus or minus here. For cos only, if you're talking about cos only, but for sine, there's no plus or minus. Even tan, we don't have plus or minus again. Okay, so those are our general solution. That is our general solution. So I hope you have enjoyed this video. Please don't forget to subscribe to our channel and also like the video. If you need assistance with maths, you can simply contact me on this number 066 276 4810. You can WhatsApp me on that number if you need preparation for your final exam or your trial examination. I will help you, or if you need classes, I'm available for that. Thank you guys. Don't forget to like and subscribe to our channel. Thanks.